Hi, this is an overview of my sous vide cooking controller. We have a standard rice cooker, which is powered through a modified timer unit. The user interface components have been removed. The relay control line has been brought out here. I've got an opto isolator to make sure that nothing nasty gets out. And all this comes together on a LPC810 mini kit board, which features the LPC810. It's a Cortex M0 MCU from NXP. Just 8 pins, 6 of which can be used, 2 are reserved for power and ground. It's got 4K bytes of flash program memory and 1 KB of static RAM. So using one of the general purpose I/O lines to control the relay in the timer unit, I've got another line used for the temperature sensing, and for this I'm using a Dallas Semiconductor DS18B20. It's a digital temperature sensor, and I've got this entombed in silicone bathroom sealant to make it waterproof. And on the breadboard here, I just have a pull-up resistor, which is needed for the operation of the DS18B20. Also, although not strictly necessary, I have this device's serial port connected to a laptop. I've got the firmware set up so that debugging and temperature logging information is sent down the serial port. The operation is quite simple. First thing, you need to put the temperature sensor into the water. Now, next thing to do is to select the temperature. Now the user interface here is very basic. So the way it works is that for every degree Celsius above 54 Celsius, you press this button once. So let's say we want to target 57 degrees Celsius. So I just press this 3 times. 1, 2, 3. It'll confirm the selection now by echoing back the number of key presses. 1, 2, 3. So our set point is 54 plus 3 equals 57. And in a few seconds, yeah, off it goes. The serial port provides debugging and temperature logging information. So if I press reset on this, it displays a welcome message, and it also queries the DS18B20 for its unique address. So that lets us know that the sensor is alive and kicking. And it also displays the starting temperature here. So these numbers are in degrees Celsius multiplied by 1000. So that's 23.625 Celsius. And I'm going to select the temperature now. I'm going to go for 57 again. So I'm just going to press this button 3 times. 1, 2, 3. So just to wait a few seconds for the unit to confirm the selection. 1, 2, 3. Okay, and it should confirm. Yeah, so the set temperature is 57 degrees, and the control algorithm now is kicked in. So this is in 2 phases. The first phase is a test firing of the element for 2 minutes, and it uses that to gauge the power of the element and the amount of water there. So based on the temperature rise after 2 minutes, it knows how much extra heating is required to bring it up to the set temperature. Once it reaches the set temperature, then a PID algorithm takes over and keeps the water at the set temperature. I've let the cooker run for a few hours, The set point in this run is 55 Celsius, and after the initial warm-up the PID algorithm takes over, and there's a little bit of oscillation about the set point here, and after about an hour or so it settles down to a very narrow range around the set point. To simulate adding meat to the cooker, I put 250 mils of cold water into a freezer bag and dropped it into the cooking chamber, and as you'd expect the temperature quickly dropped by 10 degrees or so, and the PID algorithm compensates, and again a little bit of ringing and oscillation about the set point before it settles down to the set temperature. It's not too bad. I think it's within an acceptable range for cooking purposes. So there you go, a rice cooker, a hacked timer unit, a DS18B20 temperature sensor, and a NXP LPC810 ARM Cortex M0 Plus MCU. And together you have a nice sous vide cooker.